Welcome. In this video, I'm going to teach you how to solve a Bernoulli nonlinear differential equation. The beautiful thing about Bernoulli differential equation is that you can turn it a nonlinear and you can solve it using substitution, and it becomes very similar to what we learned in a first order linear differential equation solution. So let me show you what I mean by that. So a Bernoulli equation is of the form y prime plus bx y equal to qx yn. Notice that n tells me that if n is 2 then or greater than 1, that means that we have a nonlinear differential equation, first order nonlinear. So nonlinear, okay. So once again, bx and qx are continuous functions. So I'm not going to derive how to get the general solution of a Bernoulli equation, but what I'm going to tell you is that by using the following solution, we can solve an example of a Bernoulli differential equation as follows. So y1 minus n, the solution of a Bernoulli equation is as follows: y, then e 1 minus n px dx is equal to 1 minus n qx 1 minus n px dx plus c. So this is the general solution. This is the general solution to a Bernoulli differential equation. All right. So let's say we have the following example, the following Bernoulli equation: y prime plus 3x squared y equal to x squared y squared. So in this equation, n is equal to 2 because I get it from here. And then we can use the solution that I presented to you before to get, and then solve it to get our answer. So we have y, 1 minus 2, it's minus 1, and multiply times the integral of minus 1, and then px is equal to 3x squared times 3x squared, and that's equal to minus 1 because 1 minus n. Px is equal to times 3x squared times the integrating factor minus 1 times 3x squared dx plus c. Okay, so let's compute this here because we're going to substitute it here as well. So this becomes integral of minus 1 3x squared. That becomes y minus times e minus x cubed equal to minus 3x squared e to the minus x cubed plus c. Then the right side becomes, so now we need to do a u substitution here. So let u equal to negative x cubed, and let du equal to the derivative of negative, that would be negative 3x squared. Okay, so the right side becomes, okay, so if du is equal to negative 3x squared, okay, let's see. Here minus 1 times qx actually it's x squared. This should be qx. So x squared and x squared here. Okay, so now the right side now becomes, so now we have a negative 3, so we have a negative, we have an x squared and an x squared. The only thing that we don't have here is a 3 here. So what we have to do is divide by 1 over 3. And then when we integrate, we have to put it also for the c, for the constant. So it will be as follows. You're going to see what I'm going to do. So now it becomes e to the u du plus 1/3 c. Now we integrate this, and this becomes 1/3 e to the u plus 1/3 c. Then we plug in u, which is 1/3 e to the minus x cubed plus 1/3 c. Okay, let's make some space. So on the left side, remember we have y minus 1 times e to the minus x cubed is equal to this here, 1/3 e to the minus x cubed plus 1/3 c. Now let's get rid of this here. We divide by e to the minus x all over e to the minus x cubed. So we're left with y minus 1 is equal to these cancel with this, so we're left with 1 over 3 plus 1 over c over this here, e minus x cubed. Let's simplify this a little more. So y prime is equal to 1/3 times 1 plus c e to the x cubed. Notice we have a minus 1, so to get rid of this minus 1 and let's just let y, so big y is equal to, we flip everything, so it will be 3 over 1 plus c e to the x cubed. And then of course we want a function, to make it look like a function, we have y of x equal to 3 1 plus c e x cubed. Okay, so this will be our general solution. To this Bernoulli equation. So notice we were able to use concepts that we already know to solve something that it's looks, where we have a nonlinear, where y, the exponent of y is greater than 1. Thank you very much. Don't forget to subscribe, please.